Okay, so there we go. So there we have an equation to solve. We have x plus 5 equals 13. Okay. So chapter 1's over. That was a review. And now we want to solve that equation. Now, an equation, an equal sign is like a kind of like a separating wall, huh? You've seen this before, right? The two sides are equal. That means they're imbalanced, right? The left side equals the right side. And so the deal is we want to get x alone. We want to get x all by itself. So if we want to get x all by itself, we're going to have to get rid of everything that's with the x, huh?
Yeah.
So that plus 5 is with the x. How do I get rid of that plus 5?
You change it to a negative.
Yeah, you do the opposite, huh? Yeah, you do the opposite. If you have a 5 added, then you subtract a 5. And I do it to both sides and draw a line. So see what I'm doing there, guys? I'm doing the same thing, the opposite of whatever's next to x. So if the original was x minus 5, then I would add 5 to both sides, huh? You always just do the opposite of whatever's next to x. And you do it to both sides. Why both sides? Because you got to keep the balance, huh? If they were equal before, which they were, and you treat them the same, they'll be equal afterwards, huh? So subtract 5 from both sides. And so then we get x equals, and then what's that, 8?
8.
Yeah, and we're done. That's all we need to do. X is 8, and then they just want you to type 8 into the box there. Is that making sense? Remember that kind of thing? I'm sure you've seen it all before. Okay. So here we go. Minus 7. Whoops, not 7x. Minus 7 plus x is minus 21. All right, so here's the wall. X is saying, I want to be alone. So go ahead and try that one. All right, so what do we got to do to get x alone? Yeah, the opposite of that minus 7 is plus 7, huh? Okay, do it to both sides. That way it'll cancel out. X will be alone. And then you can use your calculator or do it by hand. Was that minus 14? On that, right? You just think about gain with negatives and positives. Think about gains and losses. If the football team loses 21 yards and gains back 7, they're back 14. Or if you lose $21 and you gain back 7, you're down 14. Is that good on that? I get a bunch of water leaking through my roof. I'm going to be down a lot of money, and the roofer's going to come out. Anyway. So, all right, does that make sense? Is that good on that? Roberto is here with. Roberto, do you want to say something? Would now be a good time? Sure. This is Roberto, our assigned ETC tutor, right? He's just for us.
Yeah, so I just gave you the schedule for this week.
Yeah, I can write it up here for you.
This is when I'll be at the Tutorial Center, which is line 134. It's by the library building, a little bit towards the left side. It's near the media center where the computers are. And so at the moment, I'll be there every day from 1 o'clock to 3 o'clock, so after your class. And I'll also be there Friday from 11 to 1 o'clock. That's for this week only. We're still working on finalizing the schedule. And as I get better, information about that, I will update you. By next week, you should have more concrete action.
Okay.
But for this week only, that's when I'll be there.
What was today? Wednesday, 1 to 3?
1 to 3.
Yeah, 1 to 3, yeah.
I'll be there. That's those things.
Okay. Yeah, so Wednesday, he'll be there today after class, 1 to 3, over in LI 134, which is a library building, right? And then Friday, 11 to 1. So he'll teach you the same way, because he checks in with me, comes to lecture every now and then. He knows he'll teach you the same exact way. You won't get a different story like you can sometimes at tutoring. Great, thank you. All right, let's...
Yeah, it's fractions.
You got a fraction one on number 9?
Yeah, we're on 2.1, right?
2.1.
Yeah, number 9. It's a fraction.
Well, that's quite a difference. All right, let's see. Minus 1 plus z equals minus 10. Try that one. You can solve that one. Now, you guys can bring your computers and get your homework done during class if you can't.
Hold on.
That's good.
I was looking down here, it says 9 here,
Ah.
but that's how many I've done, okay.
All right, so on this one, Z saying I want to be alone. What do we do to get Z alone?
Add 1 and
Add the 1.
-9.
Boom, there we go. What's that, -9? Yeah. We lose $10 and gain back $1. All right, good. So yeah, I'll put it on the screen here for us all. Yeah, so x plus 1/11 equals 7/11. Yeah, fractions. So same deal. X is saying I want to be alone. Get rid of, get rid of whatever's with me. See how you can do on that one. So what do? We always do the opposite of whatever's next to x, right?
minus
So what's next to x is a plus 1/11.
Okay, so we're gonna minus, okay, gotcha.
Yeah, that making sense? -1. And whatever you do to one side, you have no choice but to do the same thing to the other to keep the balance, huh?
Right. I don't know why.
So that'll be 7/11 minus 1/11. 6/11. Is that good? Everybody happy with that?
No, it says, my expression is not, oh, never mind.
All good?
Yeah.
So here we go. X plus 1/8 equals minus 3/4. Okay, this is going to be a much harder fraction one. So give that a try. That's quite a bit harder than the other ones.
I just wanna know if I'm on the right track.
Yeah, we're just taking.
It has to be multiplied for 1 and 8 and 8.
Oh, yeah. I mean, you could do that. Yeah, we could do a multiply thing. We
There's a
could.
better way?
And there. I don't know if it's better. It's about the same. I think I'm just going to do the subtract on this one. But what you're saying is true also. I'm just going to subtract 1/8 from both sides. Here's the wall. That'll get x alone. But you're right, James. You could do it. I know some of the other ones we did like a multiply thing. And both ways are true. I think this would probably be a little easier on this one. Just subtract 1/8 from both sides. That'll get the x alone. Now the trick is though, how do you do these guys together? Minus 3/4 minus 1/8. What do you guys do? Common denominator. Remember when you're adding, subtracting a couple of fractions, you got to get a common denominator. So what's the common? What 4 and 8? What's common there? 8 itself. Huh? Make them both 8. Now, so the 1/8 is good. Just leave him alone. What are you going to do to the top and the bottom of the 3/4 to make the bottom 8 so it'll match the other one? 2, huh? Then that'll become minus 6/8. Does that make sense? So bring the minus 1/8. We don't change at all. Now we can combine these, and it's minus 7/8, and we're done. Did everybody see what we did there? So I subtracted 1/8 from both sides because you always do the opposite of whatever's next to x. That gets x on. But then to do these guys together, you've got to make that 3/4. You got to multiply top and bottom by 2 to make it 6/8. So it has the same. So they have the same denominator now. Got to make common same denominator, huh? And then minus 6 and minus 1 is minus 7, right? If you lose $6, you lose $1 more, you lost $7. Now we don't change the denominator. That just stays common. It's all good. Questions I can answer on that? Remember all that stuff? All right, I'm gonna. All right.
So could I
Question?
do it the way I was talking?
You could. You can try it on your own paper. I'll come by and check.
Then
Try that one.
reduce it.
Yeah, I wouldn't suggest it on this one. Which one, the last one? So always focus your attention on x, and whatever's next to
I
x.
understand that.
Yeah.
So then it's gonna be. Okay, am I gonna, you're gonna be negative 2/3?
So x is saying I want to be alone.
Okay, positive, yay.
So whatever's next to x, we do the opposite, huh? We do the opposite. So I'm going to add 2/3 to both sides. Is that good? Because that's the opposite
Yeah.
of what's next to x. Good so far? So the left side's all good. It's just x. We're happy with the left side. But the right side, we need to like add those guys now, huh? So how do we add those guys on the right side? Got to make the bottoms the same. Right? Now,
Gotta be one.
in this case, one of them's a 5, one of them's a 3. So remember what you do when you have like two totally, the last one was 8 and 4, so that was easier. You just multiply the 4 by 2 and it became 8. But this one's weird. I mean, 3 and 5, they have nothing in common. So remember what you do? You multiply by the opposite guy. You take the 3 and multiply by 5, you take the 5 and multiply by 3. And that'll make them both 15. Does that make sense? So you come up here and you go, okay, this one with the 5, I'll multiply top and bottom by 3. That's supposed to be a 3 up there. So that'll be 12/15. This one with the 3, you multiply top and bottom by 5.
10 over 15.
It'll be 10/15. See how it made both denominators the same?
Plus the 2 to the 12?
So I need to make both denominators the same, to make the bottoms the same. So when I'm looking at the two denominators, the 5 and the 3, I basically multiply by the opposite ones. I take the 5 and multiply by 3, I take the 3 and multiply by 5. That makes them both into 15 on the bottom. So it makes the bottoms the same. Questions?
Yeah, so is that like a rule we can do with that?
Yeah.
With something like with an odd number that none of them are
Yeah, right, when they're just like two totally different numbers, just multiply by the opposite one. That makes sense? So you have like a 5 and a 3, they're totally unrelated, nothing in common at all. Just swap them up. Yeah, the 5 you multiply by 3 and the 3 you multiply by 5. Because that'll make them the same, huh? Because they're both going to end up 15 that way.
And then see here's the
Both denominators.
do?
Yeah, right. You can't do anything until the bottom's match. Yeah, I don't know if I've said that clearly. You must. Let me write that as a note. We must make the denoms the same. Yeah, we have to do that. So now we add them, 22/15. And we're done. It's okay that the top's bigger. You can leave it that way. The only thing you can't do is if something divided out of the top and the bottom, but nothing divides here. Yeah, but it's fine to leave the top bigger. That's not an issue. It's just you can't. If anything divides, you have to do that. But nothing divides, so we're good. 22/15.
You mean to reduce? If it reduces?
Yeah, if it reduces, if you could divide top and bottom by 2 or 3 or something, but we can't. Yeah, but a lot of times I get a good question. People say, "Hey, it's okay to have the top bigger." It is. It's totally okay.
And that's even goes to if you have a 3 sets of fractions, these don't reduce, but the last one does. You have to reduce.
Got to reduce that one. Yeah. Anytime you have a fraction that can be reduced, you need to. Yeah. All right. So that's probably one. Okay. So minus 9/14 plus m equals minus 5/6. There's the wall. Okay, and you know the story. M is saying, I want to be alone. So give that one a try.
This where, because now the negatives on the whole in the front one and then the negative on the top one, it really doesn't matter if movable fractions negative.
Yeah, it doesn't matter where that, it's just a negative fraction. Doesn't matter where that negative is in particular.
Okay.
Yeah, exactly.
And that's including the negative 5, right?
Yep. So what do we do to both sides to...
Add 9/4.
Yeah, you always do the opposite of whatever's next to the letter, huh? What's next to the letter? Minus 9/14. So we add 9/14. And that gets rid of it, because the letter's saying I want to be alone. The way you get alone is you do the opposite. So now you have to work with that right side, huh? Now, you can be real tricky, or you can just say, look, I'm going to multiply by the opposite, right? Multiply the 6 by 14 and the 14 by 6 that way. Yeah. Okay, what do I say about x? So when x is saying it's always got opposite of 6x, yeah. Correct. Yeah, you gotta make that 5. Yeah, see, both parentheses top and bottom by 2. Okay, so I'm going to come up here and I'm going to multiply top and bottom of the 6 by 14 and top and bottom of the 14 by 6. Remember how we multiplied by the opposite one? Is that making sense on that? So what do we get? Minus 7. You use calculator. You know, these are big numbers if you need to. Was it 64? 84? And this one will be 54, 84. See how I made the two bottoms the same?
Because I did 6 times.
Yeah, that'll work good. That's even better. Yeah, you're using the lowest common denominator. I'm using a bigger common
Okay, got
denominator.
it.
Yeah, that's nice. And if you're doing 42, you're as a denominator, that's even better. This will work too, but 42 is even more streamlined. It's good so far? Does that make sense what I did? So I'm just keeping it as simple as I can. I'm just multiplying by the opposite. So when you have 6 and 14, you've got a couple of denominators. You just multiply by the opposite one. So I took the 6 and multiplied top and bottom by 14. I took the 14 and multiplied top and bottom by 6. Like that, right? Just multiply by the opposite one, and that does what? It makes the two denominators the same. And so now we can combine these. Minus 70 84ths plus 54, right? We just do the top. So on the bottom, whoops, I don't know what I just did there. The bottom is going to remain 84. We're not messing with the denominator at all, are we? So what happens on the top? It's just minus 70 plus 54. Use your calculator if you need to. It's going to be what? Minus 16? Yeah, minus 16. Thank you. Good to there so far?
Yeah.
I just did minus 70 plus 54 on the top. Minus 16. Now, that fraction does need to be reduced. Bless you. Doesn't it? Because you can divide top and bottom by 2 at least. Maybe 4. I don't know. Yeah, 4. I probably should do 4. That'd be even quicker. I'll do it in 2 steps. Minus 8 40-seconds, and then divide by 2 again. And it'll be minus 4 21sts. Getting a little scribbly there. So minus 4 21st. That's the final answer. After I reduce that fraction a couple of times. Is that good? On that? Questions I can answer? So
Is that negative the whole fraction or just to the 4?
really good question. It's all the same thing. So in other words, yeah, so everybody hear her question? It's a really good one. She's asking, well, hey, is that minus on the 4 or is it like in the front of the fraction? And it's actually the same either way. You can put, when you have a minus on a fraction, there's actually 3 options. You can put it in the front middle, you can put it on the top, or you can put it on the bottom. It's all the same. And Math Excel will take it in all those forms.
Can you do it real quick with the 42?
Do with the 42? Yeah, if you did it with the 42, you would take the minus 5/6 and the 9/14. Is that what some of you guys did with the 42? And you would multiply top and bottom of this one by 7. You don't need to, if you already, don't be confused by this. I'm doing something for those who need it the different way. On the top and bottom of this one by 3. So this would be minus 35 40-seconds. This would be 27 40-seconds. You combine those, you're going to get minus 8 40-seconds. And then reduce that, divide top and bottom by 2, and you get the same thing. That would be that. That'd be the other way. Questions on this one?
I have 7-6.
Yeah, what's that?
7-6. Do you get 7-6?
As your final answer?
-6, 7.
I can come by and take a look in a minute. All right, so all right, we have 3 1/4 plus x equals 6. We're trying to solve there for x. You know, x is the same old thing. X is saying I want to be alone. So what do I do to get x alone? Yeah, just, you always do the opposite.
Negative 3 1/4.
Yeah, opposite of whatever's next to x, huh? So it'd be negative 3 1/4. Subtract 3 1/4 from both sides. That'll get x alone, but how do I do the other side?
Borrow.
That is a good, if you know that, that's a good technique. Yeah. Everybody good to hear so far? The question is now, how do I do that right side? How do you do 6 minus 3 1/4? Let me give you a couple approaches. A common mistake I've seen over the years is students will go, well, 6 minus 3 is 3, and then you just bring down the 4th. But that can't be right. That can't be right. Let me give you real life. You know, the best thing in math is always to have a real life sense about you. Think about if you had 6 whole pies, right? 6 whole pies, and somebody said, hey, take away 3 1/4 of them, right? Start with 6 whole pies and take away 1, 2, 3 and 1/4. So it's 4 like that. 3 1/4. So how much are you left with? 2 whole pies and 3/4 of another one, huh? So you could just do that. You could just say, look, the answer is 2 3/4. I'm just looking at real life there. If you have 6 whole pies and you take away 3 of them and 1/4, you're left with 2 3/4, aren't you? That's one way, right? The other way will be more formal, and that would be to say, well, yeah, the borrow thing. If some of you guys might know the borrow thing, you could say, look, 6 is 5 4/4. I don't know if anybody's seen that kind of trick before. When I write 4/4, what is 4/4? That's 1. So 5 and 1 more, that's the same as 6. That's just a fancy way to write 6, right? 5 whole pies and 1 more pie, 4/4, right? And the reason that's helpful is because now you can subtract. That's the borrowing technique somebody mentioned, right? It's like taking $6 bills and turning one of them into change. Now I've got $5 and one of them in change, right? On that, my son is, tell you about my child saving techniques here, because I keep getting change. My son, when he does not follow, like, get the trash out and it doesn't happen, like, that's $1. I'm in the money zone now. You know, we're past the sit in the corner. He's, you know, like, money, money, money. So he's been bringing me his change recently. I don't know if he thinks that's not money. He'll bring me a pile of change. All right, Dad, here's the $1, and I'm getting like 27 pennies. Anyway, so that's like what we're doing here. We're taking the $6 and turning one of them into change, right? So it's 5 whole dollars and then change. It's still $6. And then we can subtract, right? 5 minus 3 is 2, and 4/4 minus 1/4 is 3/4. Same answer. Question?
Okay, you're asked to show like the work on the test.
What's that?
You're asked to show the work on the test.
I will ask this. Well, it's multiple choice in the end. I'm okay any method you want to use.
Okay,
That's
so
what
you
you're
don't
asking.
care if we just
I don't
show
care.
slides?
Fine with me. Yeah, I never care. I never care about the method. Any of those fine. Math Excel will not take this answer though. We have to convert it. See what they say up here? They say fraction. Yeah, pies are fun. Fraction. In some ways I like the pies better even. How do we convert that mixed number to a normal fraction? You remember? Yeah, you remember you multiply 2 times 4 is 8 and then add the top? Do you remember that whole thing, the converting thing? 2 times 4 is 8. So on to 2.2 we go. So now we're in section 2.2, and we're solving the equation 7x is 63. Okay, so how are we going to do it? How do we solve for x there?
Divide by 7, is it? Or
Yeah, why don't I just subtract the 7?
you have the x next to it.
Yeah, because that 7 is not added to the x, it's right next to the x, which means it's multiplied, huh?
Yeah.
Right, so I can't subtract 7, I divide by 7, don't I? We good with that? And so then 63 divided by 7, it's 9. You use calculator if you're rusty on some of those, and we're done. So when a number is right next to a letter, that's times. That's multiplied, and the opposite of that is divide. We're always doing the opposite, aren't we, of whatever's next to x. It was understood to be 7 times x. The opposite is divide. And so we did that. All right. So the ones we were just finishing in the last section, they were all added and subtracted next to x. If they were added, we would subtract. If they were subtracted, we would add. But now they're going to be multiplied right next to x, so we divide. Okay, minus x is 37. Okay, when there's just a minus sign next to x, no number at all, what number's really there?
1.
Yeah, that's really the same as minus 1. Right, a minus sign's a minus 1, isn't it? Okay, who cares? So what am I supposed to have? I'm supposed to get x alone. X is saying, I want to be alone. So what do you do to get x alone? Well, you do the opposite of whatever is currently next to it. That minus 1 that's right next to it, is that minus 1 subtracted?
Dividing.
It's what's right up against the x. What does that mean when it's right up against it? Multiply. And so right now it's in a multiply relationship. The opposite of that, opposite of multiply is divide. You with me? We always do the opposite. What's that?
Why are you doing divide by 1? Wouldn't it be a positive 1?
No. Two negatives make positive. See, I want positive x. If I just divide, it's a good question. If I just divided by regular 1, here would be the problem. Let me show you. If I just divided both sides by regular 1 instead of negative 1, what would happen is negative over positive would be negative. And I don't want negative x. I don't want anything next to x. So I need to make it positive. Does that make sense? See what we're talking about there? So I need to divide by negative. Yeah. So here's to make that positive or just, plain x. And the other side, what is positive 37 over negative 1? Negative 37. So let me hold on for a minute. I bet what's going through your mind, you might be thinking this. You might be thinking, wait a minute, Sarah, you said we always do opposite. And now you're not doing opposite. Right? Negative, you're supposed to do the opposite, which is positive. Why did you change your plan? I am doing the opposite, not the opposite sign. I'm doing the opposite operation. That's what you're getting confused on. The opposite of multiplying is dividing. That's how I'm doing the opposite now. I'm not doing the opposite sign now. That was back for adding and subtracting. Everybody see that difference? I'm doing the opposite operation. Opposite. So when you divide, in other words, you use the same sign, don't you? Let me write a note on that. So when we divide, we use the same sign. So whenever we divide both sides, we divide by the very same sign. When we add, subtract, so let me write a note for that. When we add or subtract, we use the opposite sign, don't we? Are you seeing that? So when we divide, we use the same sign, but when we add or subtract, we're doing the opposite sign. So when I'm dividing, if it's negative 1, I'm dividing by that same sign, because that way the two negatives will make positive, and x will be alone. And on the right side, positive over negative made negative. So there we go. Is that good? Does that make sense? All that? All right, so there we go. Negative x is negative 48. So same thing. X is saying, I want to be alone. Get rid of anything next to me so that I can be alone. So Give that a try. All right, so what do we got to do on both sides on this one?
The same.
Yeah, there's really a -1 there, huh? So we got to divide both sides by another -1. Is that good? Whenever you divide by the very same sign, don't you? Adding, subtracting is the opposite sign, but dividing is the very same sign. The two negatives cancel. Two negatives make positive. The other side, two negatives also make positive, or you could just use regular 48. That's good enough. Make sense on that? We okay? All right. In general, yeah, you're right. In general, I could tell you the rule that whatever we do for multiplying, dividing is the same thing. Multiplying and dividing always go together in the rules. And adding, subtracting always go together. So you're thinking right. That is exactly right. So we'll see that right here. Yeah. So x over 6 equals -6. Okay, there's the wall. Got the wall of separation. So x is saying, I want to be alone. Like, that's what x is always saying, the big loner. X is saying, I want to be alone. Get rid of this 6 that's underneath me. So that I don't even look at the other side. Who cares what's over there? Just focus your attention on x. That's where you want to look. So the 6 that's underneath is saying, you get rid of that 6 that's underneath. X wants to be alone. So how do we get rid of that 6 that's underneath?
Multiply 6.
Yeah, because it's a divided 6, huh? The opposite of dividing
Multiply.
is multiplying. Yeah. That's right. So you multiply. And whatever you do to one side, you have no choice but to do the same thing to the other to keep the balance, right? They were equal before. You treat them the same, they'll still be equal. So these cancel, and X has got his wish. He's a big loner. He's alone now. Got rid of that 6. And what happens on these? Do these cancel also?
No.
Why not? Why did those cancel but these don't? Because this is top bottom. It's not about negative positive. Right? Any 6 alone is really over 1. These are really over 1, aren't they? Right? So these ones cancel. Top to bottom cancels, doesn't it? But over here, they're both top. So they just multiply to be -36, and we're done. Is that making sense? Is that good? Yeah. X multiply? Oh, cross multiply? Yeah, that works too. That works too. Good. Is that good on that, guys? So I'm always doing the opposite of whatever is next to X. My focus is always X. If there's something divided, I multiply both sides. If there's something multiplied, I divide both sides. Right? It's always the opposite of what's next to X. Okay, so we have 3 over 17x is 21. And here's the wall, and X is saying, I want to be alone. I'm the big loner. Get rid of everything that's with me. Get rid of this 3/17. Don't even look at that 21 right now. Our focus is the X and whatever's with the X. Huh? Getting rid of whatever's with X. How do you get rid of that 3/17?
Multiply.
Multiply.
And what do I multiply by? Yeah, the upside down, huh? The reciprocal. You know that word. Even if you don't know that word, as long as you do the operation, you're good. You just multiply by the upside down. It's always the opposite, huh? We're always doing the opposite of whatever's next to X. You guys tracking with me? So in other words, I'm going to come up here and multiply by 17 over 3. And 17s and 3s will cancel, and X is alone. Now I still got to work out the right side, which I will in a second. But is everybody good with that first step right now? Does that make sense what I'm doing? I multiply both sides by 17/3 because that will get rid of everything next to X. X will be alone. Okay, now, how do I work out that right side? Whenever a whole number, like 21, is interacting with a fraction, put it over 1 to make it look like a fraction. I'll make it easier for you, right? And then how do you work that out? What do you do? Cross cancel. Remember how you go like 3 goes into 21 7 times? Remember that? And then multiply what's left over. 7 times 17. 70, 40, what is that? 119, thank you. 119 and we're done. Was that too quick? Does everybody see what happened there? Am I making sense there? So I looked at what was next to x. I multiplied both sides by the upside down, the reciprocal. Then over here, when a whole number, you put it over 1. 3 goes into 17 7 times. I'm sorry, 3 goes into 21 7 times. I cross cancel. Just use your calculator. 21 divided by 3, 7, right? But they're gone. The 21 and 3 are gone at that point. They're not there anymore. That's the part that confuses students a lot. They think they're still there. So everybody see that? The 3 and the 21 are gone. The 7 is there. And so the leftover, after the canceling, whatever's left over will multiply 7 times 7. Is that good? Questions on that? Are we still having fun? Totally. Okay, so minus x over 5 equals 11.
I will be there for the buck between one.
Okay.
At some point.
Tomorrow maybe, or...
All right, yeah, I'll surprise you.
Thanks, bro. Okay, so x is saying I want to be alone. Give that a try. Give on the cross.
It just,
Okay.
it's very hard.
Yeah.
It's gotten better since my accident.
Okay. Oh, that actually. Yes, you're always watching that. Yeah. Okay. Yeah. Even yes. Okay, so they can make some nice help.
It's something I have to look at.
All right, so x is saying I want to be alone. So what do we do to get x all alone? Yeah, well, there's a 5 divided underneath it, right? So the opposite of dividing by 5 is multiplying by 5. But so I'm going to multiply both sides by 5. But should it be a positive 5 or a negative 5? Negative. Right? Remember a minute ago we talked about whenever you multiply or divide, you do the same sign. Adding, subtracting, you use the opposite sign, but multiplying or dividing, you use the very same sign. Don't you? Why? Because I want 2 negatives to make positive. Do you see, if I did not have that negative there, and I just did a regular 5, then positive times negative would be negative. I don't want that. I don't want a negative still being on the x. I don't want anything on x. I want x totally alone, which means I need a positive x, don't I? So that's why you need a negative 5, because the 2 negatives will make positive. Does that make sense? So again, whenever we multiply or divide, we use the very same sign. If it's negative, we use negative. If it's positive, we use positive. I mean what's next to x. Whatever's next to x, we use the very same sign, don't we, when we multiply or divide. All right, so these cancel. The 2 negatives make positive. They're gone, because that's 5 over 1. They cancel. What happens on the other side? They just multiply, don't they? Just minus 55. 5 times 11 is 55. Positive times negative is negative. We good to there? So number 13. So minus 4/5 x equals 12/35. Okay, give that a try, guys. Same old story. X is saying, I want to be alone. Get rid of what's next to x.
Oh, negative, 12
Vital something happens.
times negative
Yeah,
4.
change the final
Do you have it staying like that? Just
Yeah, oh, yes, sir. Yeah, that sounds good. Yeah, I'll say when you say that, do you mean like in what I'm doing on the screen or like what you're doing? Oh, if you do need to finish, yeah, you can do late homework, it's half credit. Go back and do all the late, yeah. Guys, everybody know late homework's half credit, right? If you didn't get all the homework done, I don't know if I said that or not. If you didn't get all the homework done on time by, what was it, 11? You can go back and do late. Late homework is half credit. Work on anything you want late.
I remember now you saying that.
Did I? I can't remember what I said in which classes, to tell you the truth. So how do we, what do? We're going to multiply this one by the upside down, right? 5/4, and it's got to be negative because we want the two negatives to make positive. Everybody good with that? Multiply both sides by the reciprocal, it's called. The upside down. Why? Why that? Because that'll get x alone. The two 5s will cancel, the two 4s will cancel, two negatives make positive. That handles it, huh? That gets x totally alone in one step. Okay, what happens on the, everybody good with that side? You always multiply by the upside down. And again, you do the very same sign. Right? If it's negative, you use negative because two negatives will make positive. That's what we want. Now, how do you do the other side? Yeah, cross cancel, huh? 4 goes into 12 3 times. 5 goes into 35 7. Use calculator if you're rusty on some of those. So those are gone. What's left? 3/7 and negative. Don't forget the negative because there's this negative right here. I don't know, it looks a little funny on my sheet. Goes right there, huh?
that was the negative that was on the other side.
Yeah, that's right. Because I multiplied both sides by negative 5/4. So that negative comes down. Is that good? Does that make sense on that? Questions? All right. So minus 4/5 x is minus 24.8. Okay, that's almost the same as the last one. So what are we going to do there? X is saying, I want to be alone. Get rid of this stuff that's with me. I'm the loner. So what are you going to do to get rid of X?
So we turn negative 4 into 2.
We could. Actually, that would work fine too. I'm just going to do what we did in the last one. I'm just going to multiply by the upside down again. And the negative. Whatever I do to one side, I have no choice but to do the same thing to the other to keep the balance. Is that good? Just like the last one, right? Whenever you've got a fraction next to x, just multiply by the reciprocal. the upside down. And of course, both sides. Question, comment? Should be positive? No, because if it's positive, here's the problem. If I did positive on both sides, that would make these guys cancel, but positive times negative would make negative x. See, I don't want negative x. I want regular x. So that's why I do negative, because two negatives make positive x, or in other words, just normal x totally alone, which is my desire. Does that make sense? Everybody see why I use the very same sign when I'm multiplying? If it's negative, I use negative. Don't I? And you do it to both sides. Is that good on the left side? That gets them all to cancel. Positive, regular x. X is alone. Now on the other side, first off, is the other side going to be, whoops, I got to change the sign here. It was negative, wasn't it? If on the other side, is the answer going to be positive or negative? The final answer? Positive, because it's two negatives, isn't it? On the right side. Now, how do you do it? When there's decimals, guys, when there's decimals, I would just use my calculator. What I mean is, here's exactly what I would type on my calculator. 24.8 times 5. Don't worry about the signs. We've already worked out the signs. We know two negatives is positive. Divided by 4, hit equals. Right? Because you multiply by the number on the top, you divide by the number on the bottom. 24.8 times 5 divided by 4. Don't worry about signs. Two negatives makes positive. That's done. Hit that on your calculator and tell me what you get. What is it? 31. Try it out. So try hitting the buttons again, see if you can get 31 on that. 31 looks right to me. You guys able to get that? Yeah, looks good. Perfect. Yeah, Casio Natural Display, that's easy to use, huh? Guys getting that okay? All's well? Yeah. Yeah, remember I said don't worry about the signs. I already did the signs. Two negatives, positive. And then you can just forget about the sign. It's just easier not to have to type in those signs on your calculator, you know. I think it's easy just to do the signs. You know, you guys know the rule, right? Two negatives make a positive. So just do the signs yourself, and then just type in the numbers only to the calculator. I think it's easier.
So does that only apply to division when you're doing
Does what only apply?
negative?
Yeah, for multiplying or dividing, two negatives make a positive. Am I answering your question? So for multiplying or dividing, two negatives make a positive on that. All right. We good? Other questions on that? Okay, so notice we multiply the number in the top, right? And we divide the number in the bottom on your calculator, right? On that? All right. Okay, so here we are, section 2.3 now. We have 5x plus 8 equals 13. So these will take a couple of steps now. Now we're going to put it all together, like it says, using the principles together. So the name of the game again, x, is saying, I want to be alone. I want to be alone, so get rid of all the stuff that is with me. So what is with x that we need to get rid of?
5. Oh,
The
plus
8
8.
and the 5. Somehow or other, we need to get rid of the 8 and we need to get rid of the 5 because they're both on x's side of the wall. Don't even worry about the 13. That's not an x's side of the wall, right? It's just the stuff that's with x on his side of the equal sign that we need to get rid of, right? So that x will be alone on his side of the equal sign. So how do you get rid of the 8 and the 5? Well, you save the 5 for last. Save the number right next to the x. Get rid of that one last. First, start with the other stuff. So save the 5 for last. First, get rid of the 8. So let me write that. Save the 5 for last. Save the number that's right next to x to do last. So first I'm going to do the 8. How do I get rid of that 8? Not minus 8, negative 8. Right, because it's a plus 8. You do the opposite. Remember, when we add, subtract, opposites. Let me write that. Add, subtract, opposite sign. Always opposite. But when you multiply, divide, it's same sign, huh? Keep reminding you that. So yeah, so minus 8. See, I'm doing the opposite sign because I'm adding, subtracting. It's always the opposite sign. Those are gone. Good? And now what do we have? 5x, bring this down. And this is what, 5? Yeah, 13 minus 8, 5. And now, last step to get x alone.
Divide by 5.
Divide. But when I divide them, I can divide by negative 5 or positive 5. What does this say?
Positive.
Same sign. Regular 5. Not negative 5, right? When you multiply, divide, it's same sign. When you add, subtract, that's when you do the opposite sign. But when you divide, it's the same. If that was a negative 5x, I would divide by negative 5. If it's positive 5x, I divide by positive 5. Same sign when you divide, huh? Opposite sign when you add, subtract. All right, 5 over 5. These cancel. X is alone. 5 over 5 is? And we're done. Good on that one? Questions? Makes sense. Okay, so 2x minus 13 equals 5. There's the wall. Give it a try. X is saying, I want to be alone. Get rid of, who are we going to save for last?
2x.
The 2. You always save the thing right next to it for last. First, get rid of that minus 13. First, get rid of that minus 13. So to get rid of that minus 13, am I going to do the same sign or the opposite sign?
Opposite.
Yeah, remember, add, subtract is opposite sign. So the opposite of minus 13 is plus 13, isn't it? And so that makes 2x 18. Good to there. And then when you divide by same sign. So now the dividing comes last, doesn't it?
Yeah.
We divide by the 2. Not a negative 2, huh?
No.
Same sign when you divide. So the answer is 9.
Yeah.
We good with that? All right. All right, so here's number 5. 4x plus 7x is 77. Okay, so notice 2x terms on the same side combine, right? When you have 2x terms on the same side, like we have a 4x and a 7x, you combine them. We're combining it. What's 4x plus 7x?
Yeah.
11x. You just. Why doesn't it make 11x squared? When do you get the x squared stuff happen?
Parentheses.
If you were timesing. Yeah, we'll do that later in the course, next month maybe or something, next week. But yeah, for now, it's just regular x. When you're adding, you just add them, you don't make it x squared. So you've got 11x equals 77. X is still saying, I want to be alone. So what do you do now to get x alone?
Divide by 11.
Divide. And when I divide, what do I divide by regular 11 or negative 11?
Regular.
Yeah, you always divide by the same sign, by the identical, whatever's there. Cancels, and that's just 7, huh? Questions on that one? That good?
I'm glad I did 255 before I came in here.
That's right. It goes over all this, huh?
Yeah.
Yeah. So 6.4x minus 3.5x is minus 87. There's the wall. So you should calculate if those x's are on the same side, huh? Is that what it is? Yeah, just subtract those on your calculator. Get 2.9x. Just combine. Subtract. And you get 2.9x. Is that good? And then what's always the last step?
Divide.
Divide, huh? Divide. And whenever we divide by the same sign. So we divide by 2.9. And with decimals, I would always just use my calculator. So we know it's negative, right? Because there's just one minus sign. What is it? 30. Yeah, just divide in your calculator. 87 divided by 2.9, 30. Good on that? Negative 30, I mean. Negative 30. All right. Okay, so number 9, 6y minus 4 equals 23 minus 3y. Here's the wall. Now, notice this. Let me write a note on this one. Y's on opposite sides. So last time I wrote you guys a note about when the x's or the y's, it makes no difference what the letter is, x, y, whatever. When the letters are on the same side, that was a couple problems ago, we just combined them, right? But here they're on opposite sides of the wall. I can't add that 6 and minus 3. And well, anyway, I can't. They're not together, are they? See how the 6y and the minus 3y are separated? They're on opposite sides. So what do you do when you have the letters on opposite sides? You do the opposite of the lower one. Really, it's either one, but I'll just say the lower one. So in other words, you look at this 6y and you look at that minus 3y. Which one's the lower one? The negative 3y. You go to him, and in fact I should write both sides. Let me finish that statement. You do the opposite of the lower one, and you do it to both sides. So what's the opposite of minus 3y? Positive 3y, and you do it to both sides. And then it gets rid of one of them. Everybody catching me on that? That's quite different, isn't it? So if the letters are on the same side, just combine them. No big deal. But if they're on opposite sides of the wall, you've got to do the opposite. Try to key your memory there. Opposite sides, do the opposite of the lower one. And you do it to both sides, right? And so this will be 9y minus 4 is 23. See how that, basically you don't want it in two places. That gets rid of it in one of those places. By doing the opposite, I dropped it out at one place, huh? You know the rest now, right? Now you add the 4. Exactly. We add the 4. We save that 9 for last to divide, huh? So at 27. Last step's always divide. So last step, we divide by 9, and it's 3. Is that okay? Questions on that one? So we have 7x plus 4 is 5x plus 5. There's the wall, okay. Give it a go. You have don't even worry about the plane 4 and the plane 5. Do the x's first. It's always x's first. So you have x's on opposite sides there, right? So you got to get rid of one of them, huh? You don't want x in two locations. Two locations to serve you. You don't want that. You want to get rid of one of those locations. Okay, so again, x on opposite sides, get rid of the lower, and do that to both sides. Right? So, who's the lower one? 5x. So the opposite would be minus 5x. That gets rid of it. I do it to both sides. So everybody good with that? X on opposite sides, get rid of the lower one. So that'd be 2x plus 4. And this is just the 5 now. Got rid of the 5x. Good to there? And now you know how to do it from here, right? Now x is saying, I want to be alone. So we say, okay, subtract the 4. 2x is 1. Last step?
Divide.
Last step is to divide by 2. Boom, x is a half. Last step's always divide, huh? And there we go. Just leave it like that. Questions on that one? You doing good? We got about 35 minutes out there, about to get uglier. Are we doing okay? You still feeling fresh and focused? Sort of? Okay, so number 11, yeah. So 6 minus 2x is 5x minus 9x plus 6. There's the wall. Okay, so a couple issues going on here. First off, these two, let's just do the x's first. Don't even worry about the other stuff. Just all of our focus is on x until we get x down to just one spot, right? Then we'll think about the plain numbers. But first, we don't want 3x locations. No. We gotta break that down. So first off, what do you do about the two x's that are on the very same side?
Combine.
Fine, just combine them. Just 5x minus 9x? Exactly. That'd be negative 4x. We good there? Good for the just combine. Let's draw a little arrow there. Just combine those, right? Is that good? Now, let me let you take the next step. Now, again, it's all we're still doing the x's. We don't want two x's. We just want one. So, but this is opposite sides. So what do you do? Who's the lower one? Who's actually the lower? If I'm $2 in debt and my friend is $4 in debt, who's got a lower financial situation? Negative 4 is lower, because that's more, these are negative numbers, right? So the negative 4x is the lower one. It's more in debt, right? So get rid of that one. Get rid of the lower one, right? Get rid of lower negative 4x, both sides. So what will get rid of the negative 4x? Plus 4x, and you got to do it to both sides. That'll get rid of the lower one, huh? Good there? So what do we have? 6. It's going to be plus 2x, and that's just 6. Everybody see what happened there, right? 4x, take away 2x is plus 2x. If you lose $2 and gain 4, you gain 2. Good there? Just use calculator too. Good to there. Now, we got x in just one location. Now you know what to do from here, right? Let me let you finish it. Go ahead and finish it if you have not. All right, so subtract the 6. So 2x is 0. It's kind of weird, huh? It's okay, though. Just keep moving. What's always the last step to get x alone? Always. Divide by whatever's next to x. So what is 0 over 2? It is 0. 0 in the top of fraction is just 0. There we go. 0 on the bottom is undefined. Yeah, good memory. Yeah. We'll come to that later. Everybody good with that one, though? Does that make sense? We got it copied down? Okay, so. All right, we got to do these. All right, here we go. 7/3 x plus 1/3 x equals 5x plus 60 over 3 plus 8/3 x. That's ugly. Ugly. Well, there's a lot of ways of doing this. I'm going to suggest to you that you basically, if you have fractions, just get them out of there on the first step. Because they're a pain, they cause all kinds of problems. So generally, there's other ways, but I found it's usually easiest for students to just get rid of the fractions on the very first step. So if you have fractions in your equation, like we do, just get them out of there on the first step. Okay, great. What'll get them out of there? Multiplying through by the common denominator. Notice they all have a 3 in the bottom.
Yeah.
Well, except for the 5x. Right? So just multiply everybody by the 3. Even the 5x, because you have to do equal treatment, right? You got to both sides of the wall, equal treatment. So everybody see what I'm doing. I'm wanting, my goal is to get rid of the fractions. I don't like fractions, you don't like fractions, nobody likes fractions. Let's get them out of there. Multiply all the terms by 3, because that's what's in the bottom. And what will happen? Whoop, I'm moving the whole screen here. Are we good? What's it doing? Okay. Cross cancel. What does that leave? 7x, 1x. Everybody good so far? Let me just do the left side and slow down for you there. Everybody see what happened? Right? This is cross canceling, because these are really 3's over 1. I don't know if you want to see all that detail, but that's really what they are. They're 3's in the top. 3's over 1. So they cross cancel with anything in the bottom, right? And whatever's left over drops down. Like the 7 is left over, he didn't cancel, so he comes down. The 1 is left over, he comes down. Right? We good there? Here and here, same thing, 60, 8x. But then here, wait, everybody good there? I don't want to go too fast. So same thing as out here. 3's canceled, drop down to 60. 3's canceled, drop down to 8x. We good with all that? Well, I'm getting rid of all the fractions, aren't I? Just canceling them out of there. But what happens with the 3 and the 5x?
Can you multiply?
They just multiply. 15x. Because there's nothing to cancel. So they just multiply. Let's write that. Multiply. Does that make sense? So everywhere where it can cancel, it does. It just drop down what's left over. And right here where it can't cancel, it multiplies. The rest will be pretty easy. That's the main step. So let's just leave that up for a second. Is that okay? Questions I can answer on that? Question? Yeah.
Where did you combine the first lecture?
Yeah, there's all kinds of, there's some other really nice ways you can do it. Yeah, but you're right. That'd be 8x, 8/3 x. There's an 8/3 x over there. Drop it out of both sides. 60 over 3 is just 20. Move that to the other side, -20. Divide by 5, the answer is -4. Yeah, there's some little trick ways, but those won't work on other problems, so I'm trying to show you one thing that'll always work. Yeah. So we good to there so far? So no more fractions, right? Much nicer, right? Now, what do we do with these two x's?
Yeah.
Just put them together. Yeah, 8x, huh? What do you do with these two x's? Is it okay that they're not right next to each other? Sure, they're on the same side.
Yeah.
So what's that, 23x?
Yeah.
Good to there so far? So one's on the same side, they just combined on that. Like that, it's combined together. Okay, now, what do we do with these x's on opposite sides of the wall? Yeah, remember when we have opposite sides, we get rid of the lower one? Right? Those are on opposite sides. Who's the lower one? Yeah, the 8. So I'll write, get rid of lower x, opposite sides. X on opposite sides, get rid of lower x. So I'm going to subtract it. Now, it would actually be easier to subtract the 23x in this case. It doesn't matter which one you get rid of. You just get rid of one of them. You don't want two of them, get rid of one of them. It doesn't really. I say lower one, but generally that'll be easier, but not always. In this case, it's actually not the easier way, because that'll make 0, huh? What is that, 15x? It's okay to get 0, just keep right on moving. So 0's okay. Good to there so far? Now, we're still trying to get x alone. What do we got to do to get x alone? Yeah, now x is saying, I want to be alone. So subtract the 60 from both sides. Like that. Boom. That's gone. And we get what? Negative 60 equals 15x. Bring it up here. Everybody see what happened there? See, the left side is negative 60. The right side is just 15x. Good to there. Last step to get x alone. Divide by that 15, huh?
That's more close.
negative 4. More confusing than subtracting the 23x from both sides? Yeah, I agree. Subtracting the 23x from both sides would have been a little better. Yeah, so if you want to do that, that would be a little easier. Yeah, it'd be quicker to subtract the 23x. You'd save a step. Yeah, so yeah, in fact, let me just show it that way. Everybody got that down who wanted to see that? You got that copied down? I'm going to erase it. And say, you're right, it would have been easier to subtract the 23x from both sides. Would have saved us a step. So instead of saying get rid of lower x, I'll just say get rid of one of the x's. It really doesn't matter which one. Just get rid of one of them. So I'll say, okay, whoops, that's not right. Subtract 23x. If you want to write this down, this will be a little easier. What's that going to be? 8 minus 23 minus 15? And then just brings down the 60. Then that's a little quicker. Now what do we do to finish getting x alone? Now it's just divide by the minus. Remember when we divide, we use the same sign. We use the identical. Whenever we divide, it's just identical, right? It's a minus 15, it's a minus 15. It's just identical when we divide. And so that's a little quicker. And so the right side, it's the same answer in the end, negative 4. Save you a step. Yeah. So really when I say x is on opposite sides, you can get rid of either one. It'll work. You don't have to do the lower one. Good on that? Questions? So we need to practice. Okay, so number 13. Whoops. I'm all over the place. I didn't get the whole problem written down. Oh, there it is. You got it on your screen. Yeah. Okay. So 12 fifths plus 3y equals 6y minus a tenth. Okay. Okay, so whenever we see fractions, let me go over here and write fractions. First step is to multiply the top of every term by the LCD. Right? That's your first step. So what, as you look at those fractions, I'm looking at a 5 and a 10. So what's the LCD for 5 and 10? What's a number 5 and 10 both go into? 10. You want the bigger one. So 5 and 10 both go into 10, right? 10 doesn't go into 5. 5 goes into 10, right? So they both go into 10. And so, okay, great. So they both go into 10. What do you do about it? You multiply the top of every term by that 10. So 10, 10, 10, 10. Every term. Question? No, yeah, good question. I'm glad you brought that up. Yeah, don't do that, guys. Don't do common denominators here. I know there's a temptation. That's right. I'm glad you brought that up because I see that a lot. Don't do that. It's possible. It's way harder. This will be way, way easier. Yeah, please write down exactly what I'm writing and learn this. This will be way easier. Don't try to say, oh, I'm just going to multiply top line by 2 and it'll be 24 tenths and all. That's so much harder. No. Let me be clear. The difference, I know it's confusing. You say, well, about an hour ago, it's today even, right? About an hour ago, I was multiplying top and bottom, making denominators the same. Here, I am not interested in making denominators the same. I'm killing them. I'm going to try to use a shocking word so that you'll remember. Realize the difference here. I am not trying to make same denominators. I'm trying to get rid of denominators. I don't want any fractions. I don't want same fractions. I want them out of there. Everybody see the difference? When you have an equal sign, you want to get rid of the fractions after the first step. Much easier. Way easier way to go. So everybody seeing that difference? I'm not trying to make same denominators. I'm trying to make no denominators. In fact, what I end up doing is I end up calling the LCD a hitman. That's what he basically is, right? He takes out denominators. That's what you're trying to do, is take them out, not make them the same. That was a different situation. And it's not time to totally do all that. But with an equal sign, just know this. With an equal sign problem, fractions on the first step, multiply every term and take them out. That's what you're doing. You're not making them the same. You're taking them out. So 5 goes into 10 2 times. Look, it just took out that 5, didn't it? Everybody see that?
Negative?
Question?
Yeah, I do have a question. Why did you say 10, not 5?
Because 5 goes into 10. You want a number that they both go into.
Oh,
Yeah. And then you multiply what's left over. 2 times 12, 24. Everybody see that first fraction? What happened then? Right? So you multiply through, and then you take it out. Let him do his job. Right? He's supposed to take out that denominator. That's what LCDs do. They take them out. They take out those, let it cancel. That's its whole purpose. I had a hitman come by my office 5 or 6 years ago here on campus. I'm being dramatic. He was an official hitman, paid by the government to do that. In other words, what's a hitman in the Army called? It's not called a hitman. What do they call him? A sniper. He was a sniper in the military years and years ago. He told my son and I, my son was in my office that day, all kinds of stories about the things he had done. Anyway, so I'm just doing that, sinking that in your mind. The LCD is a hitman. His job is to take out denominators. That was this guy told me in my office. He was an older gentleman. He was back in the Vietnam War. He told me, yeah, I was just a young man, 18, 19, joined the military, went out to the rifle range, basic training. I was real good with the rifle. They tapped me on the shoulder and said, we have a special program for you. And they trained him on the rifle, and later they would take him in a group up on a high mountain, and they would point to the bottom, and they'd go, target, target. I was like, I was just a 19-year-old kid. I was taking people out. Anyway, it's kind of creepy. But he's a real nice guy. But anyway, so there we go. So you'll never forget now, right? LCD is a hitman. It is to take out denominators. That's its purpose. Let it do that. Question?
why wouldn't it be 5? Because 5 can go into 5 one time.
But 10 doesn't go into 5. Right? I want a number both 5 and 10 fit into. 5 is not it. 10 doesn't fit into 5. But they both fit into 10. You with me? You want the bigger one. It's a container. They have to both fit in. 10 will hold them both. 5 won't. Now, I know it's confusing because you think, well, it's LCD, Mr. and it's lowest common. I know, honestly, guys, I just don't have time. I can tell you the whole story later. It's the lowest among all containers. Like 20, they also fit into. 30, they also fit into. What's the lowest container they'll fit into? It's 10. It's the lowest container. That's what the L stands for.
Would that not also be the GCD?
It's not the GCD. We'll talk about that later. Grab me later. All right, so we good to there? So 5 goes into 10, 2 times 12 is 24. 3, and here, these are going to multiply 30y, because that's not a denominator, is it? That looks like a 36, but it's just a 30. So, we good there? Here, 60y, and here they cancel, minus 1. No more fractions. The hitman took them out, which makes life much easier for us. No more fractions. You see that? You see what happened? That's a crucial step. Absolutely need to master that. If you didn't understand that, go back over to the YouTube and watch it and watch it and watch it and try the math Excel problem. That's what I had to do. I had to just beat my head on math and do it. It was my life. It really was. People think you can learn math casually. You can't. You can't. It's like learning Chinese. You got to work and work and work. It's not casual. Right? So that's what this is not a sociology class or psychology or history. And I'm not putting, I love history. But those are just a little more common sense, right? It's not quite as hard. I took them, I didn't have to kill myself. Math, I had to kill myself. I had to just do the problems over and over and over and over again. That's what you need to do to pass this class. So, does everybody make sense of that first step? I rarely understood math the first time in class. I had to look at it again and again and again. That's what it takes. All right. So the fractions are gone. They canceled here and here. They multiplied where they don't cancel. Right? Everybody good with that? You cancel where you can. You multiply the other places, right? All right, now we have y's. Now there's no more fractions, much nicer. We have y's on opposite sides. What do we do when we have the letter on opposite sides? Yeah, just get rid of one of them. Usually the lower one, but it doesn't have to be. So minus 30y, right? Gonzo. Here's the wall. This is 30y minus 1. We good to there? Okay, now, right? So I got rid of, so there's only one y now. Much better. Y say don't want to be alone. What do I do to get that y alone? Add the 1. Careful, don't look over there at the 24. It has nothing to do with the 24. It has to do with the 30 and the 1, the stuff that's with y. When y wants to be alone. So get rid of that 1. Right, so what do we get? 25 equals 30y. Good to there? And what's the last step to get y alone? It's always divide, huh? Divide by 30. That's a 30. Cancels. So y is 25/30ths, but that can be reduced, huh? Divide top and bottom by 5. So y, well, what is that? 5/6? Whew. It's a lot of work. Fraction problems are tough. So you have to multiply it all the way across top, top, top. The LCDs, the hitman, he takes out. See, he took out that denominator. And what was left over multiplied, he took out that denominator and just the minus 1 was left over. He multiplied in the middle because there was nothing to take out. Everybody see why nothing canceled? This, because why? Because that 3y is not under a bar. It only cancels stuff under bars. Stuff that's regular, it multiplies some. Everybody see that? All right. I'm doing the worst of them with you. It's not all this bad, in other words. Okay. Whoops. There we go. So, let's try that one. So, 5/4 x plus 1/8 x equals 5/8 plus x. Okay. So you know what to do, right? With fractions, identify, don't say it out loud, give everybody a chance to identify the common denominator, the LCD, and then let that hitman do his job. So put it top, 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 all the way on every term, and then let him take out denominators. That's his job. So the LCD is 8, right? The LCD is 8. Everybody seeing that? Because 4 and 8 both go in 8. Right? It's the bigger one. It's the container. 8 holds itself, and it holds 4. Right? 4 goes into 8, 8 goes into 8. LCD is 8. Everybody. So I'm going to take that 8. I'm going to go 8 here. 8 here, 8 here, and even on that plane X, because you got to be equal treatment. Everybody gets one. Right? Now, why is he there? What's his job? Take out those denominators. Don't play games with making denominators. Kill them, kill them, kill them. Straight across the board. Kill those denominators, right? Take them out. That my friend years ago that was the marksman in the military, so he was telling us all these stories, my son and I, all these stories in my office, and exciting stories about all these battles and crazy things he was in. And then I noticed he had a glass eye, and I said, hey, is that where you got your glass eye? Was that in one of those battles? And he's like, no, I got the glass eye. I was out mowing my lawn, and my neighbor was out there using an edger, and it flicked a rock over and it popped out my eyeball. Isn't that crazy? He did all that military stuff, but he lost his eye in the front yard. But then watch out when your neighbor's weed eating. That's kind of a funny story. All right. So take them out, right? 4 goes into 8 2 times. You with me? Leftovers multiply. So you cross cancel. The 4 is gone. The 8 is gone. What's left over? 2 times 5? 10x. We good there? So it took out the denominator, and what was left over multiplied. Right? Try the next. It's going to happen in this next one. Take it out, and whatever's left over multiplies or comes down. 8, 8, gone. Took it out. 1x. Good? Just keep taking them out. We want no more fractions. Do the next one. Gone, gone. And lastly, 8x. There's nothing to take out on that last one, huh? It just multiplies, 8x. We good to there? No more fractions. It's always much nicer once we get those fractions out of there. Right? So do this first step. Okay, can you take it from there now? So now, these guys are same side. They just combine, right? Same side. They just get together. 10x and 1x, 11x. Good like that. Good to there. So, what do you do when x's on opposite sides? Yeah, get rid of one of them. Doesn't really matter which one. Usually the lower one. Yeah, minus 8x is perfect. Gonzo. Right, so this gives us 3x is 5. Last step is always divide. 5/3. We got it. Is that good? Getting comfortable, more comfortable with those fractions? LCD, top, 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 top. Take them out, take them out, take them out. Multiply leftovers. Question, James?
So, on the first one,
Uh-huh.
you had the 8, but then you had to, however many 4 went into that 8, correct? Which was the 2.
Yes, exactly. I divided 4 into 8 2 times. And then the leftover, 2 times 5 is
Yeah,
multiplied.
because if they're not the same denominator.
If they're not the same, there's going to be something left over.
You have to,
And it multiplies, whatever's left. Exactly. So if they're not the same, like the other ones were the same, so they just vanish.
Yeah.
But if they're not the same, they're going to have something left over. It's going to multiply whatever's left over. Yeah, exactly right. Okay, so we have 8x minus 4x plus 7 equals 25. Okay, so no more fractions. That's nice. That, I think we did all the fraction ones, or maybe all but one of them or something. So most of them are not fractions. There's only like 4 of them in this section that are fractions. So we did the worst of them. All right, so try that one. What do you do when there's a minus sign up against a parenthesis like that? Remember that? Yeah, that minus sign is really a minus 1 up against that parenthesis, and it needs to distribute, huh? Like anything up against the wall of a parenthesis. It needs to distribute through those parentheses, doesn't it? It's kind of like water up against the floodgate. We got water in there, don't we? And so when the wall comes down, the water goes in. Like a dam gate, up against the dam wall. When the wall comes down, the water goes in. James.
so if there's nothing there, you're just gonna put a 1, correct?
Right.
Because you need something outside the parentheses to work with.
You don't have to. You can just do the negative sign if you want. It doesn't matter if you prefer it. It doesn't matter. Put a 1 or just the minus sign. But my main point is it's up against the parenthesis wall, so it's going to hit both the things on the inside, not just the front one. It's
Right.
going to hit them both, right?
Yeah, it's gonna turn the distribution.
It's going to distribute. Yeah.
The positive to negative on
Exactly. We good with that? And now these guys will combine like that. They just subtracted, right? 8 minus 4 is 4. And now x is saying, I want to be alone. So what do we do?
Add 7.
Add the 7. You know the rest, right? 4x is, what's that, 32? What's the last step always?
Divide by 4.
Divide. We always divide by the identical twin. Same sign, same everything, huh? So that's 8.
Another question.
Question?
When you put 4x, 8x minus 4x, and on the other side of the 4x is another negative, that wouldn't turn that positive, only if it was similar?
Okay, good question.
If it was
This negative,
4, if it was negative 4 and then you had a negative 7 on the other side, then it would make that 7 a positive?
no. So this negative right here is only on the 7.
That's what I'm saying.
Yeah, just on the 7. Right. All right. Oh, that's a bad one. Okay. So 3. Wait, I need more room than that. Let me move it over here. 3 bracket 5 minus 3, parenthesis. I'm going to use an X instead of a B. Minus 5 equals 5, bracket 3, parenthesis, 5x minus 4 plus 2, bracket, minus 26. Wow. Look at that. That's awfully ugly. Okay. All right, here we go. You ready? 5 minus 3 is 2. Like that. Is that good? 5 minus 3 is 2. Everybody with me so far? Let's do this last one. It's important. It's the worst one, looks like. Everybody good to that first step? Everybody see what I did? So I wrote it all down, and then I subtracted 5 minus 3 is 2. And that's wrong. If I do that, the rest of the problem is wrong. Just quit now. So I wanted to make sure you see that, because that's the mistake I see lots of people do. Why? It's all garbage at this point forward. Why? Why can't I subtract 5
You
minus
have
3?
to do what's inside the parentheses.
Yeah, remember the order of operations. Multiplying comes before adding and subtracting. That 3, minus 3, is really a minus 3. He wants to multiply those parentheses. And
12 minus 3.
hello. That minus 3, it will multiply before he will ever subtract. Remember the order of operations. You don't need to remember the whole PEMDAS or whatever. Just remember this, and you'll be fine. Adding, subtracting is last. If you just remember that, you'll be good. That's the mistake everybody makes. They add, subtract too early. So just remember, adding, subtracting is last. Last. So, can't subtract right now. No. That needs to wait. So that minus 3 times 4 is minus 12. Minus 3 times minus x is plus 3x. Minus 5. Everybody good with that so far? I multiplied. Multiplying comes before adding, subtracting. Everything comes before adding, subtracting. Adding, subtracting's last. Okay, keep going. The 3 is going to distribute. 15x minus 12. Now, do you see how, guys, I dropped off the parentheses? Do you see how they vanished? But the brackets are still there. How do you know when you're supposed to drop something? Whenever something from the outside goes in. That's why I do the water up against a wall on a dam or something. It's kind of like that. You know, the brackets, the parentheses. It's like there's water. When does the water go in? When they lower the wall. So when you drop the brackets or drop the parentheses, that's when something from the outside goes in. And that's what I did there, right? I let that minus 3 on the outside of the parentheses go in, so there's no more parentheses. I let this 3 on the outside of the parentheses go in, so there's no more parentheses. I haven't let anything from the outside of the bracket go in yet, so they're still there. Everybody see that? So let me lower the wall. Yeah? Oh, no, there's no divisions up there, although some might look like it. All right, so let's keep going. So 5 minus 12, negative 7. Whoops, I'm getting too scribbly. So, plus 3x minus 5. And what's this? 15x. So, minus 12 plus 2 is minus 10. We good to there? I just combined, you know. So, now this 3 is going to go boom, boom. So, the brackets are going to drop. Something from the outside's going in. Minus 21 plus 9x. This 5 is going to go in. The brackets are going to, what was that, 75? X minus 50. Whew. Made it through. Got all those parentheses and brackets out of there. Now let's combine minus 21 and minus 5. What is that? Minus 26. And minus 50 and minus 26 is minus 76. Good to there. Now, what are we going to do? Well, let's do the x's first.
Okay.
We have x's on opposite. Let's first deal with it. We don't want two x locations. So what do we do? Yeah, get rid of the lower one. minus 9x from both sides. Boom. So minus 26 will equal something. 66x. Yeah. Minus 76. Kind of running out of room. We good to there? Have to squeeze it in maybe over here. Minus 26 is 66x minus 76. Okay, what do we do to finish getting x alone? Add 76. What's that? 50 equals 66x. Last step, divide by 66. And that's reducible. Oh, I'm tired of this problem at this point. Divide by 2. 25/33. What? What a painful problem. 25/33. All right. There we go. So, what's due next time? Yeah, but I mean the homework. 2-1, so the homework due on Mondays. 2-1, 2-2, 2-3. We didn't get to 2-4. So I'll remove that. And we're not going to be able to have our test on Monday. Because I had scheduled a test. We're a little bit behind. We didn't quite get through 2-4. So the test is Wednesday. Our test will be next Wednesday. Exam number 1. Test number 1. Next Wednesday. And of course we're doing clickers. Anybody not on Math Excel, Monday morning at 8 a.m. I'm dropping from the course. So make sure there's 5 or 6 of you who are on if you want to be in this class. So clickers on Monday. Clickers will be for points. Make sure you have them with you. Have a good day, guys.
Are the tests on math exam?
Practice exams? Yeah. They are.
I mean, like the test, like on Friday. Yeah, the test that we're doing this week.
Oh, the test will be taken right in class.
Okay, I didn't know if that was going to be on.
Yeah, no, nothing electronic or anything. That's just right here in class, Cantron, multiple choice. Yeah.